Generative AI is probably today one of the most exciting technologies that we have and the most exciting development within the AI world. And Chat GPT is one of the applications that uses that technology. Chat GPT took the world by storm. As it was introduced by OpenAI in November. In a week, it had more than 1 million users. Just out of curiosity, with the hands, how many of you guys tried Chat GPT yourself? All right, great. If you have not, I really recommend you trying it, because this is the first time when you interact with a system that creates some sort of experience of you talking to an intelligent system. What I want to do today is talk a little bit more about the technology behind ChatGPT and what's actually revolutionary about this. So first of all, just sort of a quick primer on how we build model in machine learning. And so what's generative AI is in general. Generative AI is a class of models that are capable of generating new content. Typically, in machine learning, we first looked and collect the data, and then we train the model to recognize patterns in the data, like step number 1, step number 2 here on the slide. What has been added is this ability from recognized patterns to generate new type of data, new elements, because you know what the pattern looks like. And you can generate text, image, video, audio, code. And what's extremely interesting, that you can go from one modality to another. For example, from text you can generate images, from text you can generate audio, and can go in any direction in here. But what I want to make the point that really ChatGPT is really just the tip of the iceberg. What's really interesting and what's revolutionary and what will make a transformative effect on the economics is those large language models, or another way it's called foundation models, that power that application. How did we get there? Well, as Ben mentioned, in the 70s, we worked mostly with expert systems. And over there, expert put rules into the systems. But you cannot come up with enough rules for every situation in the world. And so the expert system didn't work that well in the real world. Then there was a time of machine learning where engineers provided to the machines examples and trained machines how to use those examples by creating features. Then came a decade of deep learning, and deep learning allowed us to work with the raw data, but still need quite a lot of human intervention in terms of bringing in sample data. Finally, we got today to this very, very new concept of large pre-trained models. And I believe that this is really revolutionary. Now, let me try to go a little bit deeper in technical details and explain to you what those models mean. I promise this is the most technical slide I have in presentation. So the concept, the idea is that instead of training the entire model, you split the training into 2 pieces. At first, you pre-train the model, and you pre-train it without human intervention on the raw data, with machine trying to just predict what's called masked talking. Masked talking is a very simple idea. You, for example, hide one word in a sentence and you make machine predict it. And that's how machine learn the patterns in the data. And that's where you put lots and lots and lots of data. And then you have this pre-trained algorithms. Then you take it and fine-tune it or adapt it to solve various tasks. For example, you can provide a few examples of questions and answers, and then the system will be able to answer questions, do sentiment analysis, do image captioning, other things. You can also train the system to support a dialogue. And in fact, that was done with Chat GPT. But again, the power lies within this concept, within the concept of creating a very large model, pre-training it, and then fine-tuning. This is very different from what has been done before. This type of models has been in use in production for the last 3-4 years, and finally they made it into the open, made it to the public through this Chat GPT. Now, there is this aha moment. When you try Chat GPT, you kind of taken by the surprise usually by the consistent conversation that the model can support. You can also be surprised by its problem-solving skills, because you can ask the question and the model will actually can give you an answer and can even go step by step in explaining what it is. It can actually even write programming code. And writing programming code is actually much harder than just plain, for example, English, because every small mistake will make program unusable. So these are sort of aha moment for the end user. But there are also surprise moments for the developers. Because in fact, for those large models, you just train them to predict next token in a sequence of tokens, or next word. And all of a sudden, the model exhibits very interesting properties, and model by itself capable of solving problems it was not taught to do. So that has even got its own name. It's called emergence. So the ability of the model, with increased size of the data that is given to it, get new skills of being able to solve various types of problems. It's called emergence. And that's a phenomenon that puzzles developers, puzzles scientists. In some sense, for the first time, build a system for which we know how each part of the system operates, but we don't understand the limits of its capabilities. There is this emergence. The more data we take, the more interesting things it can do. And then it can be trained on a very, very few examples. And in many tasks, currently it outperforms all other small models. So the concept right now, there is this one large model that collects all the data in, performs better than building a lot of small models. So it's out here, right? We've seen Chat GPT. Google yesterday just announced releasing their own version of Lambda through the model called BART. And so we are here, we're going to use with these models, live with these models. So on the first take, what are they good for? Well, it's really a great tool to create sort of first draft, right? Share ideas with you, maybe creating summary. It is actually not so good for searching information. It makes factual mistakes, very well documented, and shown that, so I wouldn't suggest using those. And actually, it's also not very good to giving you some very deep insights. Its sort of answers are quite dull in the sense that it collects and aggregates information and just presents it to you, right? So it's not that original. And very important to remember that there are some things that actually raises red flags when you try to use it. So things like hallucination, which is sort of model can actually make things up, right? Can sort of come up with facts that do not exist. And there is really limited explainability, and it easily integrates all kind of copyrighted or protected material in their answers, and you as the end user will not know it. So it is a great tool. It's really great conversational layer for all kind of systems. It will definitely be a huge boost, will give you a huge boost to your productivity. It can be a brainstorming partner, but you need to treat it carefully right now. Because this is really not completely safe technology in terms of the information it provides to you. If we switch hats and go a little bit more about business, where we see right now possible business implications is really at this moment, it's more about operational efficiency improvements for the business. Some obvious applications like for marketing, which is creating copywriting, or creating media content, personalized offerings, and we'll see a lot of startups already doing this. Very interesting applications will be in information technology. As I said, it's going to be a conversational layer on top of the search engines that will allow you to summarize, aggregate all the information you have in your enterprise and present it to the users in a human-readable format. And of course, it is a great tool for software developers and for testers to, again, accelerate the process. But not only that, if we look at the operations, clearly chatbots, emails, robotic process automation improvements. And I think very, very important point is that this type of models create natural language interface to pretty much anything. Think about this. The model, you speak to the model and you put the commands in natural language. It converts it to the programming code, and code can be executed by robots or by any machines. So all of a sudden, with natural language, you can control any machinery. And that's what be transformational. But I also strongly believe that one of the biggest effects that we're going to see will be within R&D and within science. Because in science and in research, it always takes a lot of time to conduct experiments. You try various things in the wet lab. You know, the experiments fail. You try it over again. It costs a lot of money. It takes a lot of time. And what the models, generative AI models, not Chat GPT, but generative AI models can do for you is actually take some of your experimentation from the wet lab to sort of in silico, which is it can generate, for example, new type of molecules or new types of material structure. And then it can calculate and predict its properties. So all of a sudden, instead of 5 to 10 years for new drug development, it can be done much faster within several years, and there's a lot of startups that are already doing this type of thing. With material science, you can actually try to predict and try to construct new materials with this. Remember, for scientists, the big part of science is really this, you know, ideas, this inspiration, this ways to come up with new things. And that's what generative AI does for you. It really combines things and gives you the stuff to work on, right, to start from. So I strongly believe that this type of technology will really accelerate scientific discovery and brings us new drugs, new materials, bring it much faster to the market. So, but in order for this technology, and again, remember that though the technology by itself as generative AI is probably 3-4 year old, you know, Chat GPT is only 3 months old and we're already talking about it right now here at the major conference. There are a few things that need to be done in order to bring it to enterprise, right, to make it enterprise level solution. First, it should be customizable, so we should be able to fine-tune the technology based on the data of the enterprise. There is definitely a question about privacy protection and IP protection because the models are trained on public data. There is a big question about security, preventing data leak and information leak. And of course, if we want to use this within the enterprise, you need to have audibility. So explainability of the model, so we can actually be able to explain what the model does. If you try to play with this Chat GPT, you realize at some moment you can actually even talk to this model as you will talk to a human. And that will create this sort of illusion of intelligence. That model is intelligent. Well, I have to disappoint you, it is not, right? It is just a statistical model that is very good at predicting next token or predicting next word and becoming very fluent in language. And we as people who possess certain traits, we think that if somebody else possesses that traits, he possesses all the traits you have, right, as a person. Well, the model, again, it's statistical model. It does not have any embedded logic, and so it's not thinking. Even when you try with Chat GPT and add, 3 plus 5, and it gives you the correct answer, it still doesn't know that 3 is a number and 5 is a number. It looks at them as characters, and that means it has seen somewhere many times in the text that it used to be trained that 3 plus 5 is equal to 8. And that's what it gives you back. And that's why it makes also silly mistakes. And as on a previous panel and a previous talk has been discussed, these models are not really intelligent. Now, the big question is, if this is a step towards intelligence, well, maybe yes, maybe no, but what's very clear, it's probably a little fragment that shows us that it is possible to create conversational systems that for us will be almost indistinguishable from humans. And I want to just point out on a quote from Jan LeCun that the reasoning abilities or the perceived reasoning abilities of the model is really comes from this large associative memory. So the models have seen a lot, remember a lot. And we, because of that, start imagining that the model is actually logical and has some intelligence. Again, it's a statistical model. One other important topic we need to keep in mind is, of course, human and machines, and what's called today an alignment problem. So the notion that we need to make sure that machines understand what we really want from them, right? Understands our queries. and our intentions, and actually operates with respect to those intentions. And of course, there is a big question about the bias, how we can actually remove bias from the decisions, from the solutions that machines propose. But here, we really need to remember that the algorithms, they're really trained on the data that are generated by us, by humans. And so they're a reflection of us. They're a reflection of the biases that we have in the society. And so it might not be possible to fix algorithms without sort of improving and removing biases from our own society. And I want to conclude the talk with this idea that what we're seeing right now is really a next step in democratization of AI. And what I mean by that? Well, first of all, natural language interface allows users to easily interact with the systems. It used to be that you have to be a programmer to interact with AI system. We talked about AI for a long time, but it was software engineers and machine learning experts. Now everybody has access to real power of AI through tools like Chat GPT. And so it really allows you to use and experience AI firsthand. The fact that the models now can be pre-trained and then sort of adapted for different tasks opens doors and removes barriers for a lot of businesses to start using that. Those businesses that previously just didn't have enough data or didn't have enough compute power or resources to build very large models. And again, large models means high quality. And finally, there is this order of magnitude improvement in the quality of the solution that these models provide. And so that makes them applicable to very, very many problems we couldn't use them for. With that, I want to conclude and just mention that all the illustrations for this presentation has been done with Midjourney, and by taking some queries, sending them to Chat GPT to expand them, and then sending to Midjourney to generate the images. And with that, thank you very much.